Hello everyone and welcome to the first session of our Generative AI course. In this course, we are going to start from the very basics of Generative AI and gradually move towards building and designing production grade AI systems. When people hear Generative AI, they often immediately think of ChatGPT or other AI chatbots. But Generative AI is much bigger than chatbots. Generative AI can generate text, code, images, audio, video, and many other types of content. Many more importantly, Gen AI is changing how we build software. Instead of writing explicit rules for every problem scenario, we can now combine software with powerful foundation models that can understand instructions and generate useful responses. In this course, I want us to understand what is happening behind the scenes. We will learn we will learn about AI fundamentals, large language models, transformers, prompting, embedding, RAG agents, evolution, security, LLM ops, cloud architecture, and finally, enterprise AI architecture. So, our journey will start with the fundamentals and gradually we move toward the level of an AI architect. So, let's go to the next slide. What is generative AI, right? Generative AI refers to the artificial intelligence system that can create new content based on patterns learned from the data. So it learns some of the patterns from the huge data and it will generate its own content in that context. For example, if I ask an AI model to write an email, it generates an email. If I ask it to write a Python code, it will generate that Python code. It will provide an image. You provide a prompt for image generation and it will generate and give you a nice image. So what important here is generation. No, it will generate the new content. So generally the traditional AI systems focus on tasks such as classification and prediction. For example, a traditional machine learning model might predict whether a transaction is fraud or the customer is like to leave. A generative AI model can actually create something new, a response, a piece of code, a summary, an image, or any other type of content for that matter. So another important characteristic is that these systems can understand instructions and context. We not just necessarily have to write a separate program for any possible question. We just give the prompt and it will give the response. So we can give a model an instruction and relevant context and the model generates an appropriate response. This capability is what makes generative AI an extremely powerful tool in building the intelligent applications. So go to the the path of generative AI. Let's just discuss. So before we go into deeper of the generative AI, let's understand where it fits within the large AI landscape. So think this is an evolution, right? So first we have the artificial intelligence. That's a very big concept. It refers to machines performing tasks that normally require human like intelligence. So inside Gen AI we have machine learning. So machine learning is part of you know artificial intelligence inside AI. So instead of explicitly programming every rule, machine learning systems can learn from patterns in a provided data. Then we have the deep learning, right? So deep learning uses neural networks with many layers and has been extremely successful for areas such as computer vision, speech recognition, and natural language processing. And then we arrive the latest or modern Gen AI stuff. So Gen AI builds heavily on deep learning techniques and large foundation models. So large language models are one of the most important uh, examples. That's what we call LLMs, right? So we will be discussing about LLMs in very detail in coming sessions. So I want you to remember this path. So AI is a broad field and machine learning is from part of it and it learns patterns from data, and deep learning is uses a lot of neural networks to to analyze the data and to give the to perform a particular task. And modern generative AI is a it uses a large foundation models to generate a new content. So you should understand this relationship before actually understanding all the generative AI course. So, how our generative AI is different from the traditional software? Let us look at one of the most important differences between traditional software and generative AI applications. In traditional software, we generally define our roles. and we provide inputs, the application executes that predefined logic and will get the output. For example, imagine application calculate the pricing of a product on any site, right? So we define its rules, and then we give the instruction and it will give the output based on the rules that we have provided. But generative AI is little different from here. So we cannot provide the each rule as a program, but we can provide a prompt and the context, and then the model actually executes that one, right? The model then generates an output based on what we have learned. This introduces something very important. The output can be probabilistic. If I ask an LLM the same question multiple times, the exact wording may not always be identical because it is generating the data in that context every time. That means traditional software testing alone is not enough. We also need a specific evaluation. We need to ask, is this the correct answer? Is this relevant, or it is grounded on the data, or is it safe for that matter? So why these concepts this is why the concepts such as evolution, guardrails, and observability become extremely important when we build production grade gen AI systems. So now let's go to the one of the important topics in gen AI. The first one is LLM, right? So LLM is nothing but large language model, its full form. So now let's talk about one of the most important topics for this modern gen AI technology. So models such as GPT, Cloud, Gemini, and many open source models are examples of large language models. At high level, an LLM is very large neural network trained on enormous amounts of data. During training, the model learns patterns in language and other information. But there is an important concept we need to understand, that is called tokens, right? An LLM does not directly process a sentence exactly the way a human reads. The input is converted into tokens. These tokens could represent words, parts of words, punctuations, or other pieces of information. The model then processes these tokens using its transformer architecture. So transformer is again architecture is another very important concept. So we will be learning and doing some examples on the transformer architecture in coming days. During interference, the model generates the response one token each at a time. So whenever we work with LLMs, the concepts such as tokens, context window, interference, inference, latency, and token cost must be extremely important. These concepts will appear repeatedly throughout this course. So now let us see how an LLM works. Let us simplify what happens when we send a prompt to an LLM. First, we provide a prompt, and for example, we might say explain Kubernetes to a beginner. Then text is converted into tokens. Whatever the prompt we have given, that will be converted into tokens. Then these tokens are feeded into a transformer model, right? The transformer processes relationship between the tokens and uses the context to determine what should come next. The model predicts the next token, then it provides sorry, then it predicts another token, and this process continues repeatedly until the response is completed. So the in simple, the path will be like this. We provided a prompt, and that prompt converts prompt will be converted into tokens. Then tokens will be fed to transformer. Then transformer will be creating the next token prediction, and finally the response is given back. So of course the real architecture is much more sophisticated, but I'm trying to explain in very high terms. So we have attention mechanism, multiple layers, model parameters, embeddings, and many other components. But for now, let's this simple model is enough to understand. So later in course we'll go deeper into transformers, attention, inference, and model architecture. So let's see a generative AI or Gen AI application stack, right? One of the biggest mistakes beginners make in thinking that building a Gen AI application is simply means calling an LLM API. That's not at all the actually original purpose of this Gen AI application stack. In reality, the model is very one component, right? So let us look at the complete stack. At the top, we have the application layer. This could be a web application, mobile application, or chatbot, or anything that we generally use. Then I'm sorry. Then we have the orchestration layer. This layer decides what should happen with that request. Then we have the model layer where we interact with one or more foundation models. But enterprise applications usually need more. We may need to RAG to retrieve the information from the company documents. We may need tools that allow the AI to call APIs or perform actions. We also need security. We need evolution to measure the quantity of responses, and we need observability to understand what is happening in the production. So when we say GenAI architecture, I'm not only talking about LLM. I'm talking about the entire ecosystem around that model. So let's see the key concepts in GenAI concepts. There are several concepts that we repeatedly use throughout this course. So as I was saying before, the first one is tokens. So tokens are the inputs or the units of the large models, for the large language, for the language model process. Then we have the context window, especially the amount of information a model can consider within a request, right? Another concept is embeddings. Embeddings allows us to represent information as numerical vectors so that we can perform semantic similarity such as. So we will be discussing about embeddings in detail. They are simply vectors, and I will explain how they work. Then the very extremely important topic is RAG, no RAG systems. The full form of RAG is retrieval augment generation. So RAG allows us to retrieve the information, relevant information from external or enterprise data, and provide into the LLM as context. Then we have agents and tool calling. Agents can use models together with tools, APIs, and memory to perform more complex tasks. And finally, we have fine tuning. So fine tuning allows us to adapt a model for a particular behavior or domains. We'll spend significant time on this all of these concepts in upcoming models. So, why enterprise GenAI is quite different? Building a simple GenAI demo is relatively easy. Building an enterprise GenAI platform is completely different challenge, right? So, imagine we are building an AI assistant for a bank. We cannot simply give an application access to all the banking information. We have sensitive customer data. We may have compliance requirements. We may need authentication and authorization. We need to protect personally identifiable information. We need to think about prompt injection and data leakage. We also need to think about sorry, hallucinations. Uh, what happens if the model gives a confident but incorrect information? Then there are performance considerations. How quickly we should the application respond? How many users should it support? How much will each request cost? And once the application is deployed, how do we know whether the quality is improving or getting worse? That's why enterprise Gen AI requires much more than a simple LLM. It requires architecture, security, evolution, observability, governance, and operational excellence. So, I'm sorry, where this course takes you. So now let us take a look at where this course is taking us. We are going to start with fundamentals. First, we will understand AI, Gen AI, and transformers and LLMs. Then we move into prompt engineering. After that, we'll learn embeddings, vector databases, and RAG. Then we'll move into AI agents and orchestration. After understanding the application layer, we'll move towards production. We will learn model serving, evolution, LLM ops, observability, security, and cloud architecture. Finally, we'll combine all of these concepts into enterprise AI architecture. The objective is to build practical projects along the way. I don't want this to be a course where we simply memorize definitions. We will build systems, look at architectural diagrams, make technology decisions, and understand trade offs behind these decisions. By the end, I want us to be able to, to look at the business problem and answer what AI solution should we build, which model we should be using. Should we use RAG, fine tuning, or an agent? How do we secure this one? How do we evaluate it? How do we scale it? And finally, how do we design the complete system as an AI architect? So that's how I have defined this course, and I'm sure this course will help you in your Gen AI learning journey. And all the best. Thank you.